It's 17:01. I think that's a good time. We'll head in. We got a lot of things to talk about today. So officially, welcome everybody to today's short circuit on the topic battery trading and repurposing for second life applications. My name is Maximilian Renner. I'm Communication Dissemination Exploitation Officer at EITR Mobility, and I will be hosting today's short circuit. Before we head in, I'm going to give you a quick outline about what you're going to hear and see today. First of all, I'm going to give you a short introduction of BatteReverse, who we are, what we do, and our activities and where you can support us. Then, just a second, if you could mute your microphone during the presentation, it would be awesome. Thank you so much. After the quick introduction, I'm going to hand over to William Bergh. He's going to give us an introduction on battery trading and marketplace trends. And after that, my colleague Ola will hand over for the panel discussion in the Q&A section. Before we have our webinar, our networking session at the end of the webinar. Everybody, please, again, if you have any questions, put them in the chat. We're going to answer them during the Q&A session. And please turn off your camera if you don't want your camera to be recorded. So let's hop in. Who are we? BatteReverse is a Horizon Europe funded project. Just, I can hear some, exactly. Thank you so much for muting yourself. I will try to find the participant and mute them. Anyways, about BatteReverse. We started our work about 2 years ago in May, and we are working on unlocking the full potential of lithium-ion batteries. We want to develop a next generation process to increase the safety, efficiency, and sustainability of lithium-ion battery. And who are we? We are 10 European partners located all over Europe, and our consortium is comprised of different innovation actors, research organizations. We have OEMs also on board, and SMEs. And why do we need BatteReverse? Why do we think it's important what we do? So as of now, there is no virtual space for sharing information regarding batteries. Every battery holds a lot of information and a lot of value regarding its origins, where it's been, if it's been damaged already or not. But for now, this information is only shared with certain stakeholders and not broadly available. Also, until now, there is no universal process for discharge and energy recovery, meaning a lot of batteries at the end of the first life, if we want to remove or recover the leftover energy within those batteries, every organization has more or less a different mechanism on how to do that. And without having universal process, it's very inefficient and it's also more complicated. The same thing applies to the assessment of the state of health and the state of safety of batteries. In 2025, we still don't have a standardized process to make it more efficient and also more efficient. Another thing is transporting EV batteries is still very costly due to their size, the associated risk involved, and also their weight. The whole transportation process is way more demanding than for other products. And for dismantling batteries and sorting them, it's still highly dependent on manual practices involving human labor. This increases the risk for the parties involved and is also way more exhausting. And this brings us to BatteReverse's objectives. We, as a Horizon Europe funded project, we're working on 4 or 5 objectives. One of them, for example, is battery assessment. We want to increase the speed of the battery assessment with machine learning algorithms and acoustic testing. We're developing special safety packaging with sensors to reduce the thermal runaway risks. And also, we're improving human-robot collaboration to bring in more automated services when it comes to dismantling of batteries. And what I mentioned before, the information stored within the individual batteries is not shared broadly as of now, and we're going to change that. We're going to work on a battery data space with battery passport functionalities and standardized labeling. And we're not doing this alone. We have a great community as of now with more than 500 battery enthusiasts and professionals. And we're continuously trying to improve our services and tender to your needs. And we want to hear how we can improve the community better to your needs. So we prepared a short little survey, and if you have 2 minutes, it would be great if you could answer a survey on what you want to see more of on the community after the event. And now I'm going to head over to William Bergh, founder and CEO of Cling Systems. He's going to give us an overview of battery trading and marketplace trends. Thank you so much.
Nice. Thanks for the intro, and thanks, Maximilian, for having me here. Thanks for the full BatteReverse team. I've been following your work now for a while, and it's nice to see you still talking along these very important questions. I've been given 15 minutes to go through the market update. So here, let me know if you can see the slides.
Everything works perfect.
Brilliant. So yeah, first of all, thank you very much for being here. Good to see so many tuning into to this topic, which is the best topic of all topics in the world. So I'm very happy to be here. Over the next 15 minutes, there's three things I want you to take away. First, from my perspective, is on the $20 billion idle battery opportunity. Go through what idle means in our world. Why it's hard to trade batteries in the circular value chain, and basically ending up in how to solve those and what Kling is doing in all of this. A little bit about myself. I founded Kling in 2020. Back then, I did my master thesis at Northvolt on reverse logistics at Northvolt's recycling team called Revolt. Was looking into packaging and transportation and collection and all of that. And so based on the thesis, I founded Kling. It's a long-lived passion to figure out how to get batteries to circularity. Little bit of background on Kling though, and the importance of trading as a whole. So trading is for reuse and recycling is more than a tool for sustainability. Like sustainability is just one of the various things, but trading is probably the key, probably the most important driver for strengthening the entire battery ecosystem. At Kling, we've been doing that for a number of years now and completed hundreds of end-to-end transactions towards reuse and recycling across Europe, North America, Asia, Middle East. And end-to-end means finding supply, acquiring that, finding buyers, selling it, completing the full logistics and the reporting to authorities, etc. In parallel, we've been building a platform for automating all of these different steps. It's now over 500 companies in soon to be 50 countries that is signed up. And to this platform, it's basically what I'm going to end up with is how we're kind of doing a big relaunch of everything we built so far. And we've raised some money from investors around the world, which are amazing. That's a bit of the background. So let's go into what's up with the world of battery trading. What's going on out there? And many of you know, probably has this idea or the feeling that the battery industry is slowing down and it's going very slowly, but it's actually picking up speed. It's just here in Europe that it's not very obvious. In 2024, we had the world's largest demand ever, over 1 terawatt hour. And most of it is driven by China and Chinese EVs, obviously. But it's cool to see how fast China is taking over the EV world. And we have this event here in Stockholm called Beers and Bats that we had last Thursday. Best event. Please come next time. It's somewhere before summer. Um, and we had Bo Nordmark on stage, who was part of setting up an European Battery Alliance. He's a board member or the board advisor to both Northvolt and Verkor and etc. Like a very experienced battery person. He threw out some interesting numbers. One of which is 3 years ago, Europe and China exported equally many cars, and today China exports 6 times more than Europe. So in 3 years, 6 times more, most of which are battery powered. But at the same time, the production is very, very high, almost twice the demand. So it causes this massive oversupply that many talks about, but it's hard to kind of understand how big it is. Um, in Hans-Erik Melin's newsletter he sent out today, so maybe not everyone reads it immediately, but I recommend you do. But where he states that all three Korean battery producers lost money in the Q4 2024, which is the first time ever. So the battery producers are struggling, and all of them in their European factories, so LG in Poland, Samsung in Hungary, were running at less than 50% capacity. So they're trying to slow down production and they're trying to wait for demand to pick up, but there's a massive oversupply at the moment, which is dwarfing everything that comes to like end of life and like real end of life. So by our very conservative calculations, there's probably over $20 billion worth of idle batteries stuck in the value chain. And what we mean with idle batteries is that they're not used in any application. It may be cells, it may be modules, it may be packs. There's probably less packs because integration is quite late in the production stage, but it's a lot of cells, probably a lot of modules out there. It comes from overproduction, oversupply, a lot of canceled sales contracts, abandoned projects. And in this number, 20 billion, we're excluding all of these cosmetic issues, recalls, end-of-life batteries, where end-of-life could be categorized as end-of-life products and end-of-life waste, where I'm very against end-of-life waste. I don't like it. It's terrible for circularity. It makes logistics terrible, and we should only grade safety. We shouldn't, and we'll probably get to this when we talk with the Logbots, that moving hazardous waste is terrible, and we should just concern safety. My opinion. Anyways, so if you sit on a lot of batteries these days, you have these massive inventories, and you've been holding them for months, probably years, then you're not in a good position. Lithium prices are falling very quickly. Same with nickel, cobalt, just on the overall price of cells and packs, it's dropping very quickly as well. So because of this imbalance of high production, low demand, just last year the pack price dropped 20%, meaning that anyone sitting on these idled batteries lost 20% in asset value, and at the same time just accumulating costs. So if there's one thing you should take away from this very brief session, like please start figuring out how to efficiently and compliantly sell your batteries now. Because what's happening at the moment is that the value of the batteries is decreasing very fast, and at the same time they accumulate costs, accumulate capital costs, warehousing costs, labor costs, testing costs, cost of charging them and figuring out what to do with them. So one thing, get good at selling batteries. And now to the problems we're doing so. So if you sit on battery stock, if it's idle, and it doesn't matter if they're used or unused. Unused is almost equally hard. Selling them is so much harder than it should be. 3 main reasons. Accessing the market is like finding a needle in a haystack. It's such an opaque, fragmented market, and it's hard to know who are the buyers, who are they. And even if you do know who they are, it's really difficult to time their demand. It's hard to know when they would need exactly which batteries. So a typical deal, it's not in some trading parts of the value chain, they can be done fairly quickly within a couple of days. But most, if you're procuring for a second life project, it's once a year, or it's 6 months, because there's so many different steps of testing and evaluating, So finding the market and finding the right buyer at the right time, very hard. And then if you found a buyer, then they must have all the right information. And even if you do have it, just hustling everything together, all the data sheets and all the MSDS and having the UN 38.3 at hand is a challenge. So having the right structured information is currently putting a pretty high risk of failing on any of the 4 Cs, which would be compliance, claims, confidentiality, and just credit risks. thirdly, it's again a little bit back to this first point that the market is it's like a spot market. It's really hard to claim future supply as a buyer, and it's hard to lock in any future demand as a seller. And so it's this spot trading, and you're negotiating with multiple players around the world all the time. And what you're using is WhatsApp and email, and you have like PDFs, and that you gathered from one team member over here. You have one data sheet from over there. Maybe they're not complete. They all always look different. Maybe you have it on the right level. So whether it's cell, modules, or packs, da da da. So there's like no good tools for managing this complete end-to-end transaction. And here on the left, you see like how we typically receive information. It's in WhatsApp, it's running texts, it's pictures in WhatsApp, it's da da da. Sucks. The buying experience for reusing recycling sucks pretty much too. One trader just told me last week that getting reliable data on battery supply is like pulling teeth because the sellers rarely know what they have, and even if they do, they're not very eager to share it. Others say that they could do more deals in parallel if they had better tools. So due to this like very big market friction, again back to Hans Erik Melin at Circular Energy System or Storage, 49% of Europe's previously projected recycling capacity for 2030 has been delayed or cancelled in the last year alone. So in the beginning of last year, the beginning of 2024, let's say there was 100 X in 2030. Now, end of 2024 and beginning, only 50 of those remain. That's a big number. And it could be that it's hard to build a battery recycling plant. There's many different things that is really, really difficult. But one thing is timing the market. Probably too many went to market too early. That's one big problem. The other one is that they just don't access the supply because the supply is locked into a bilateral contract. So it's just so hard to actually find that needle in the haystack. That's terrible. So trading and making it less, like removing friction in the trading, is not just a tool for sustainability. It is really what can balance out the entire battery ecosystem. So that's a little bit to what we're doing. We're trying to figure out and launch and roll out a product that makes it easier for sellers to sell and buyers to buy. It's like providing better growth, like maximizing the value of those batteries by selling faster and having better data on it and reaching more buyers, while protecting integrity, which is probably the most important thing in the trading world. Like you can't get burned too many times. And anti-complexity, just removing all these messes of just having to negotiate here and there and just keeping track of deals and sharing information and da da da. So like smoothness, making this smooth is not like just for it being nice, but it's really, really important that the battery industry like steps up and has better ways of taking care of batteries from a trading perspective. So for anyone interested in this, what we've been doing over 5 years is wheeling and dealing, like buying batteries, selling batteries, doing all the logistics, etc., building this platform on the side that's aggregated now close to 3 gigawatt hours of listed supply, of which we traded quite little of. And the reason is because it's so hard to match supply and demand. But what we're doing now is that we're kind of bringing all these 5 years of experience into like a more cohesive end-to-end tool that we just want to bring out to the market. And what we're doing now is we're launching this through March. We're now running it with a couple of pilot customers and around the world, and now we're starting to onboard those early adopters and in March. So if you are interested, either take your phone and scan this. I'll put a link in the chat as well. But that's a brief, probably more than 15 minutes on the $20 billion idle battery opportunity, why it's so hard to trade, and why you should sign up to our pre-launch today. Thank you.
Thank you very much, William. I'll take over now as we head to the panel discussions. So first, an introduction. I'm Ola. I'm working with Bergh. We are responsible with AIT Urban Mobility for the BatteReverse project. We organize the webinar as well. We execute the webinar as well. I would like the panelists that has been invited to give a very brief introduction of themselves and what the company do as well, just to paint a picture of what we expect from the discussions. So William, you already went. Elias from Logbat, if you can go.
Yes, thank you very much. My name is Elias Neumann. I'm working with Logbat. I think a lot of you guys have already heard of us. We build boxes for safe transportation of all kinds of batteries and also transport them ourselves from all our customers across Europe and across all borders. So yes, very, very much looking forward for this panel discussion. Thank you very much for the invitation.
Awesome, thank you. Prince.
My name is Prins Doornekamp. I'm the founder and CEO of NOOS, and NOOS is specialized in life extension, mainly by repair and reuse.
Awesome. Aaron. Yes.
Hey, sorry, my camera was being a bit slow. My name's Aaron. I'm the business development lead at a company called Gaussian. What we do is we enhance battery performance using magnetic fields, so we can increase the charging speed and cycle life up to 6x improvements as a drop-in solution. And before that, I spent about 4 years modeling the costs to produce batteries and where the technology is going.
Thank you. We have a star-studded panel. A question, a note to the audience, if you have questions, put them in the chat, because towards the end of the panel discussions, we will take your questions. And yeah, we look forward to a very interesting one. So the first question I have is for William. So from your presentation, which is very insightful, you mentioned this thing about the overcapacity of new batteries and how this can impact the economic viability, for example, of trading end-of-life batteries. In your opinion, in your operations as well, how do you think we can manage this fluctuating supply and demand, for example? What do you think is the way forward?
Yeah, the way forward is less friction, more transparency. There's really something to battery passports. I believe it makes sense that they exist, but it's far from them being available in the aftermarket. If they go into new batteries in 27, we're going to see them in the aftermarket in 37. So that's pretty far away. So in the meantime, we need to figure out ways to communicate better and share information of batteries better. That's what we're doing. But if there's one thing we could all kind of collaborate around, I think Elias, you probably agree. But how should we ship batteries these days if the new ADR regulations now demand that you need a available copy of the UN 38.3 to ship batteries? So that's something that took force in 2025. So you can't ship batteries now without that certificate, which is only available from the battery producer. And it's really hard to get. And even if you ask them, they don't really know where it is. So like we should somehow, go together and say like, hey, we should put all of these UN 38.3 documents here so they're easily available to make it easier to ship batteries. That's one thing. On the viability is that it's hard now for second life batteries to compete with first life with cheap LFP batteries that have a warranty and last for many, many years. You can have extended warranty for up to 20 years now. And they're now approaching 100 euros per kilowatt hour on a plug and play system. It's hard to compete with, especially with European labor and high certification processes. So for second life, it's probably going to be in ex-Europe. It's probably going to go to India. It's probably going to go to Africa. It's probably going to go somewhere that makes sense. We see lots of batteries going to Ukraine, and that's where they also make some probably, hopefully, good value in the short term. But this blocking of putting up barriers and making it harder to export black mass, making it hard to export batteries as a whole, I think Europe will suffer from increased barriers in the long term, for sure. So I'm pretty against the increasing barriers, even if it results in batteries being exported and not being treated here.
Yeah, I can see how that can play out. If I follow up on this now with Aaron, for example, with your experience working on developing battery costs in the past, also now what you do as well, which is like trying to extend battery life. And what we've discussed, like the second life applications for battery, for example, depends on the steady supply. How do you see like the conflict, or how do you think these two areas, for example, extended battery life and also having second life batteries, like play a role in the secular space?
Yeah, so I think the first thing to consider, as William mentioned, is just how quickly the battery industry is growing, both from a supply side but also a demand side. I mean, a couple of years ago, the demand was so low, and now we're up above a terawatt hour. So there's just kind of this need for more batteries, and desire for more batteries. And this is both in kind of well-known markets, like big passenger EVs and trucks, but also lots of niche applications where maybe the second life makes more sense, because people are doing kind of retrofits or classic car conversions or something like that. But then on top of that, by extending the first life of a battery, it doesn't mean you can kind of never get to second life. It just might take a little bit longer. And as we see maybe a diversification in the cathode mix, and batteries are reaching end of first life differently at different times, we might have streams of kind of different chemistries being available at different points for their second life. And if that's extended by a couple of years, or maybe the batteries can cycle harder in operation and still reach kind of second life at the same point. But then the second area is you can also increase the usable life of second life batteries. So something we're looking at doing is applying our technology to batteries in their second life. So then those batteries last longer. So then it's not a problem that the first batteries last a bit longer, because everything lasts a bit longer and you're kind of delaying that recycling piece even further.
Yes. Yeah, it brings me to Prince quickly. So Prince, your company works very much with repairing and repurposing battery, for example. What are some like market trends that you've seen already based on what we just mentioned now that you think it's going to influence the supply and demand for end of life batteries?
Yeah, we see a big increase in customers that want to do repair instead of buying new. And when we started back in 2019, it was mainly driven financially, but now the sustainability part becomes way more important. So there's more willingness within an organization to be more sustainable. On the other hand, the battery manufacturers, they don't build batteries to be repaired or being reused. So there is a big gap between what the customer wants and what they get. And especially if you look at e-mobility, small e-mobility mean e-bikes, scooters, mopeds, but also a lot of industrial niche markets. Those batteries are never built for reusability or repair at all. And I think there's a big step the industry can make, and that would also allow more easily use of second life batteries or cells. And we talk all the time about batteries, but I think in the battery you need to look at the cells, the mechanical parts, and electronics, and you can see that they're separate things, and the life cycle is also quite different between those parts. And so yeah, there's still a lot to do, and I agree with what the other panel members are saying. The battery passport, I think, will become a very important part of the industry. Because what William said, getting UN 38.3 reports, it's not easy. We work also for battery OEMs, and we do in-warranty batteries for them. But even then, it's hard to get those certificates because it's somewhere in the organization and nobody knows where it is. And if you get something, it's the wrong version. So yeah, that's the.
Yeah, I can imagine. Yeah, it brings me to the next one, just to follow up on that as well. It's a question for Elias now. So your company works in the logistics for battery, for example. You've mentioned some of the challenges that we're facing already. From your point of view, from what your company is doing as well, what would you say if you were to bring us to speed really quick? Like the biggest challenges, for example, with transporting these used batteries, the level of complexity, for example, or how does that affect?
Yeah, well, obviously the biggest challenge is the logistics itself, right? So you have different sizes of batteries, different chemistries, as increasing sizes of batteries. You have larger batteries with trucks in various different applications, and those have a bigger safety risk inside of them, right? So you need different packaging materials. You need to be aware of which state the batteries are in. Are they damaged? Are they undamaged? Do they require special containers? And William, you mentioned that what are the classifications and what are the restrictions of them, right? Is there an ADR application? What are the ADR applications? Are we talking about hazardous waste? Are we talking about products or waste? So there's a lot of things you need to consider when transporting batteries. And as mentioned, you need a lot of documentation. You need a lot of documents and laws to be fulfilled. You need a lot of fulfillments, and yes, this is a lot to handle, and not everyone can handle those restrictions, but you have to be prepared and for every eventual situation that can arise. And yes, the more batteries are on the market, and we talked about this, the end of life market is not where we expected it to be at the moment, but it will be there, and the question is when will it be there, and how do we handle those batteries in this case? And we have to prepare. We have to check whether the laws, especially the ADR restrictions, can be complied with, and that's pretty much the biggest challenges we have to face these days. And this is especially for the recycling part. So when talking about hazardous waste, yes.
Great. If I zoom in on that a bit, so for example, there's certain EU regulations related to battery, related to waste, for example, regarding like logistics and the transport of used batteries, like you would do. How do you see the EU regulation? For example, we take an example of the battery regulation. Is it helping you? Does it create additional orders? How does that play out?
Well, we obviously need some kind of frame to handle such batteries, or handle anything to be precise. But first we have to clarify what we need to do to be able to handle such transports, right? So if we're talking about Europe-wide operations, we obviously have to talk about cross-border transportation. This is always combined with some form of notifications. So you need a special document or notification to actually transport hazardous waste across borders. There's a lot of flexibility you need to be prepared of, because there's a lot of bureaucracy within the countries, and a lot of frameworks you have to comply with. We talked about ADR, we talked about the local laws that also apply, obviously, and all the local laws in the different countries kind of differ from each other, and especially waste transport obviously requires additional permits. So the challenge is to comply with the whole EU regulation, which is important. We need regulations to be able to transport or handle anything in this regard. But we also have to comply with all the highly complex individual laws within the countries, and this obviously creates a lot of hurdles to overcome, but also it's very much important to have those in place.
Yeah, thank you. Now I go to William, for example. So keeping this a bit more practical, there's an article, for example, I found on your website, which like paints a picture of the complex paperwork you need to do a single trade, for example. I found it very interesting because just to do one trade, it was so complex. And the screenshot and the paper, can you like paint a picture for us, for example, how you simplify this challenge or like how you go about it on a day-to-day? I think that would be interesting to see.
Two ways. Either we step in and broker the deal, where we basically do everything for both parties. Secondly, which is what we're rolling out now, is the tool that basically replaces us in that sense. So starts with a deal room to which you upload the information you have, and it guides you on what's needed and what's missing and so on. There's some very early stage AI in there that also looks at what's in there. If there's any, like, is there any data points that don't make sense? Like you can't have certain mixes of data. So early feedback on the information you've submitted, to which you then start sharing that with a bunch of buyers. You enter a deal room, you have all the terms and conditions nicely structured, you have all the informations that you need to kind of agree on from a contractual point of view, and then all the information that's needed to kind of complete like the logistics and so on. So just getting one source of truth for seller and buyer. So that's step one. And then from there, producing all of the documents that's necessary. I put a link here in the chat. I think there's like, depending on when and if, etc., there's like up to 14 documents for each shipment, which is horrible. So you can read that article if you really love understanding the documentation of a shipment. Then it's basically just more structure. Basically, no, like there's very few people who trade every day. It's typically some kind of ad hoc thing that you need to do. You know, it's not your main job. And then what we do is like we help guiding the people in doing that. Today, quite manually, very brokerish. We can also buy the batteries ourselves. So we have the capital to carry the costs, and we can actually be the point of contact on the invoices as well. But moving into rolling out this system that makes, actually connects buyers and sellers and just kind of carries them through a deal.
Okay, that's very clear. I would recommend the audience as well to check out the article. The link is in the chat. Paints a very good picture. Now, if we switch a bit, now I would come to Prince, for example. So we've talked a bit about battery chemistries, for example, and how this can impact battery trading. In your experience and the operations that you carry out as well, how would you say there's changes in chemistry, like we're seeing now, LFP coming into market very heavy? How does it impact your ability, for example, to repair or to repurpose batteries?
Yeah, for repair, it has no influence. The only difference is basically the voltage. That voltage range is slightly different per cell. So that doesn't make a huge difference. What you see in 2nd-life, that it makes a huge difference because of the low pricing at the moment of LFP, lithium iron phosphate. There's very little demand for NMC. The advantage of LFP is more cycles, it's more stable, so less chance of a thermal runaway. It often can deliver more power, so especially for energy storage systems that people want to build with it. Then it's more difficult to sell, let's say, the older automotive modules, for example. And On the other hand, automotive modules are nicely built, high quality, so that gives them purpose for other parties to build something with it. So and we have to see, but it looks like what we see in the market, that there is quite a big shift from NMC to LFP. And so it has to be seen what we can do in 5 years with NMC, if there still is a demand for it. I don't know.
Yeah.
One other problem I didn't mention for LFP is that they are ridiculously expensive to recycle. And so for the total cost of ownership is quite high actually for LFP, and people underestimate that. So if you at the moment look at recycling companies, they can charge you up to 6 or 7 euros per kilo to recycle LFP, while you pay 2 or 3 euros per kilo for NMC. And that's cost you need to factor in your total cost of ownership, because it can be quite costly.
So with different chemistries, for example, comes different challenge. For example, with repairing, you don't have a lot of challenge with that. But with repurposing, for example, or with recycling, like you mentioned, depending on the chemistry, you need to find a new client that can help you with that, and that can raise cost.
Yeah, and that is often in repair, that could be a problem, because the client doesn't factor the high cost in. So they say, please return it. But if a battery is dangerous, then we cannot return it. Yeah, we need to return it in a very expensive container with high cost. And so then you get batteries. Yeah, I also call them idle, but it's a different idle than William mentioned. But yeah, you get batteries in nowhere land, let's say. And that's actually quite dangerous, because there are batteries that are not solid, let's say, anymore. There's something wrong with it, and people store it somewhere because they don't want to pay for the high cost.
And we mentioned briefly in the presentation as well, like the longer your battery stays idle, the more the value goes down. So that's something to keep an eye on for sure. Now if I come to William as well. So from a technical perspective, if you look at our advanced diagnostics, for example, it can help you to reassure buyers about safety, for example, and also the estimated value you can get from your battery. But they also like add some complexity and some cost for sellers. How would you say it's important to balance this cost, and also making sure that the people that wants to buy, they know ideally how much value is left in the battery? How do you balance this?
I'll try to give a brief answer and then or response, and then also Edvard from whatever raised his hands. He's probably more suited to answer this question, anyways. But the testing is hard. All cells are quite different, both on the cell format side, but also how how they've been used and how degraded they are. It's how they're packed into modules, how those modules are packed in the packs and systems. But there's, as far as I know, there's no one tool fits all, which is quite difficult. And it's also we haven't really seen a lot of tools that are easily integrated and like available in the market. There's some really promising companies like Novos is testing, 2nd-life is testing, BatteReverse is testing. But it's very, very good. It's like testing is necessary. It's fundamental for trading batteries in that are used. The tricky thing is where to test. Like you could send out testers to where the batteries are, but then you need the people there being trained to be able to test with many different types of testers that they will receive from time to time, because they will never have the same batteries all the time. Or the batteries can be sent to a testing facility, but then the question is, who carries the cost of that transportation? And it might be the seller, it might be the buyer, it might be a shared cost. But from what we see, it makes a lot of sense to send out testers to the sellers if the batteries are large enough. So if it's a megawatt hour or more, it probably makes sense to send a tester there before sending a lot of batteries to a testing facility, and then learn that, okay, no, they're not worth anything because they're old. Anyway, Edvard, what do you think?
Yeah, sending testers to partners hasn't been on my mind before,
No?
as you
Try
said,
it.
like, well, we usually go and we have a voltmeter, like costs $5. Check the terminals, check if the cell balance on some samples is good, and then basically you can figure out if you really want to invest really more time to understanding if this stock of batteries that's been sitting somewhere for 5 years could be even usable. There's a lot of things around the technical and safety consideration, and you guys, I don't know with LFP in this, and the issue is that most batteries have been produced in the last 2 years. Most electric cars have been pushed on the road in the last 2 years, and these batteries, like, okay, 2014, yeah, they started manufacturing the BMWs, the I series here in Europe, or an own electric car. And those modules from those cars are still on the road today, and both those battery modules are now on the second life market. But with LFP, what you don't really see is that there's like 2% of the cars on the road now, here in Belgium or something, is like LFP. LFP is a really small margin of the actual cars in Europe, for an example. So those modules, we're gonna only see them in big quantities in some time to really compete with NMC modules, for an example. There's a lot of technical considerations for the OEMs as well on these modules, on how they test it. The dealership just checks the voltage and on their computer see that they cannot use it anymore, and sometimes send it to second life. But there's a lot of points that you can touch and understand on how to make this market overall better and easier for all of the involved parties. I'm just gonna let you go forward with the presentation, and then maybe further on step in again. Okay?
Thank you. Thank you for adding clarifications to that. Prince, you raised your hand. You want to add to that?
Two small things. First of all, the automotive industry is not so big. If you look at the whole lithium battery industry, it's only 30% or so, and meaning that 70% are other markets, and they use way more LFP, for example, than in the automotive. So I agree on the automotive part that will take a while before they come out of commission for first life, but there is a lot out there. On the other hand, on the testing, I think testing makes quite a big difference if you're testing new cells, overproduction, or you need to test used batteries. And if you need to test used batteries, I would never recommend to do that on site, because you never know what you encounter. And so the chances of risk, the risk of the situation. On the other hand, you also have rules and regulations. So in most warehouses, you're not even allowed to open or not even charge a battery. So that are things most European members are more aware of. For example, in the Netherlands, we have here already quite strict rules for storage, for example, the PGS 37 -2. We also see now in France that they are working on new legislation. So there are definitely things to consider if you want to do testing. And if you do want to test, then a voltmeter only gives you very little information. So the preferred way would be EIS, electrochemical impedance spectroscopy. A mouthful. The only problem is it's very temperature sensitive. So that again, if you really want to do an assessment, it's not that easy to give good quality check on used batteries, unless it was already built in the battery that it monitors its life, and then you can use that data for making an assessment.
Awesome. Thank you for the clarifications. Now I see the time and I'm a bit careful. We would have a Q&A from the audience towards the end of this. Please put your questions in the chat. You can raise your hands as well, so you get a chance to talk to the panelists. Now I would zoom forward a bit, and Yeah, we have a style. It's a true or false kind of style. And the thing is, we want you to pick an opinion, pick a side, and then you provide a bit more context just to get a bit more insight on where you stand related to questions, for example. So you get a prompt, and then you have to choose a true or false, and then you defend your answer in the sense. This is to get a bit more insight. So the first one, for example, is for William. You pick a side, true or false. Unsold battery inventory loses so much value that after a few years, the recycling is only the best option, for example.
Yes, depending on where in the world. It's in Europe, that's probably more true. In India, they're really good at harvesting whatever value is left. Same thing with friends in around Africa, in Kenya, in Nigeria. They're amazing at repurposing. Here, recycling is probably the way to go, if that recycling is happening here or if that recycling is happening elsewhere. Does it make sense? Olamilekan, I don't know if we lost you or if you lost me.
Yeah, you can hear me now. Am I good now?
Yeah.
Okay. Yeah, that's my network. Okay. The next one is for Aaron. This is a question related to challenges we've talked about now with battery overproduction, for example. Do you think the resulting price drops as well that comes from it is like a net positive for Europe, for example, because we think it can accelerate EV adoption and maybe achieve cost parity with internal combustion vehicles? What side do you stand on?
I think this is really interesting. I think it's true, especially if we look from an environmental standpoint, which is moving to EVs is better for both kind of global emissions, but also local city emissions and kind of local air quality. So moving as quick as possible, both from an EV standpoint, but also from a stationary storage standpoint, and enabling more solar to come online because of kind of higher grid penetration with those batteries is all good. I think it's really interesting though, because it's obviously the flip side of, do you want very cheap electric vehicles with Chinese batteries, maybe good for the planet, versus having kind of more expensive batteries, but having your OEMs who are local maybe not fold and still be profitable and have kind of jobs for people. So I think it's an interesting point, but I think if there's a way to coexist with cheap batteries at some level made locally, that's definitely kind of the best way forward.
Okay, so you lean more on it's true, it's a net positive.
Yeah.
Now the next one is for print. This is true or false. Repair and remanufacturing should take priority over recycling from both the cost efficiency and circular economy perspective.
Absolutely true. That is, if you can use the product, it's always cheaper, always better for the environment than recycling and buying new.
Okay, but it's really direct and strong opinion. Anybody has a counter argument to that? To say the three, for example, should go along together. Okay, seems to be a unanimous decision. The next one is for Elias Logbat. The current EU regulations on hazardous waste logistics are overly complex and they drive up costs by incentivizing overly cautious safety designs and processes. Where do you stand on this?
Well, it's kind of a difficult question. As I said, it's kind of true and kind of false as well, because you need regulations, right? To have a frame within. Well, you need borders to where you can actually operate, right? But also individual solutions are very, very difficult. Different systems, different authorities increase bureaucratic efforts. And I think, William, you said it at the beginning regarding the battery pass, or well, in general, digitalization would help a lot to simplify processes. help efficiency and will actually reduce costs at the end, right? So digitalization is necessary to streamline those processes and to meet those deadlines better, to be able to handle new regulations and to be able to actually make sure that waste streams don't add up where they shouldn't be, right? You need the regulations, but digitalization would help to fulfill these regulations a little bit better.
I have some thoughts on this as well, and I agree with you, Elias, that sometimes they're really necessary, and it's not bad per se if they're stringent. It's bad when they are unclear and sometimes contradictory, and when it's hard to navigate, and that takes time. I would rather have clear and strict regulations than like loose and unclear, which has been. So even if it's getting more stringent, I'm kind of for it because they're also getting more clear.
Thank you for adding that. That brings us to the end of the true and false segment. Now we will take questions from the audience. So if you want to ask your question directly, you can raise your hand and join the queue, and then I can call you up to speak. But for now, I would pick the questions from the chat. So we have a first one from Tom. Is asking on the recycling cost of LFP. Is this affecting the second life cost of LFP batteries? And how is the recycling liability passed down in second life? We will take this one. I can read this again if you want.
Yeah, please read again.
Okay, on the recycling cost of LFP, is this affecting the second life cost of LFP batteries? And how is the recycling liability passed down in second life?
Yeah, I could comment in a way on this, that usually when LFP battery is cycled, it's at 80% of the remaining capacity. So when you compare new LFP module, when you overall compare the system costs of mobility applications or whatever applications where you need batteries, battery is a marginal cost in that. Even in battery energy storage system, the container parts, the cell price, the module price is in 50s or hundreds, 50 or 100 euro, and the other cost is 500 and 1,000 euros. So what I'm saying is that I'm not sure if people are really interested in cycling down LFP batteries. If those LFP batteries are new old stock, 2 years, 3 years old, whatever, you test the remaining capacity, do the spectroscopy, it's a good battery. Yeah, then there is an interest. But the batteries that are going to come from these container parks, it's going to be a hefty challenge to. Nobody is going to build a container park with 80% old batteries when they have new Chinese batteries. It just doesn't make sense, and you don't have enough applications where to then stick those big container park batteries inside. So recycling, everybody thinks about recycling, and when you buy these LFP modules, of course, you should have some strategy of 6 or 5 or 3 euros, hopefully one day after 10 years of life spent in a system, that you could maybe achieve. It's just I think it's a negative equation from my point of view. So circularity should be premium valued for the value of the overall product.
Interesting. Tom, your hands is up.
Yeah, maybe my question was not fully clear. Let me maybe clarify. I think it was mentioned that recycling of LFP battery comes at a pretty impressive cost. It's probably like up to a few euros per kilogram, depending on lithium price and so on. But how is that liability passed on? Like if you sell a second life at a pretty cheap value, like at the end of life, the person that has bought it from you will have to recycle it, and then it becomes a liability. Will that person have the right to come back to you? Will you refer them back to the OEM who has originally put that battery on the market? So I'm wondering, like, how is this recycling liability handled, and how is that responsibility handled down the supply chain in the Second Life setup?
Should I go? You can probably nuance this, but so Second Life batteries are also kind of put on market, and so whoever the remanufacturer is holds the producer responsibility and should carry the costs of recycling. There is also a middle step where there's some ambiguity in the new regulations that states anyone preparing for Second Life is also taking on the producer responsibility, which kind of releases the original producers or OEMs of that liability. And then this is where it's weird for car dismantlers, where if a car dismantler takes out the battery from a car and kind of sells it or kind of do something with it, is that, making them liable for downstream whatever happens? I don't think that makes sense. But there's one paragraph that is kind of hinting towards that in the new regulations. But whoever rebuilds a Second Life, puts that Second Life on the market, they are the ones that are the producers of that system and should carry the cost of recycling.
Great. Prince, yeah, you want to add to that?
Yeah, William just said it in the last part. It's the one who creates a new product with it and puts that in the market. That's the one who is responsible. That's the current interpretation is of the producer's responsibility. So you have a battery. The original manufacturer, the original importer, I have to say, who brought it in the European Union, that had the producer's responsibility. If we take it apart, we do a registration of that. Then with that, he's released from the producer's responsibility. And we only sell parts to companies that build products out of it. And then that one builds a product and put it in the market, gets a new producer responsibility for the product. And so that new manufacturer, that's what you can call it, that company or person carries then recycling responsibility. The battery passport will be a great help in this, because then you can follow the whole chain and it is more clear if it is passed over or not. Because in some cases you could also agree to not pass it over in a contract. In some countries you have compliance schemes where you need to pay upfront and register upfront, but also pay upfront for recycling. For example, in the Netherlands, we do that for e-pack, so e-bikes. That would make life much easier to understand where the responsibility is and if they're already paid for.
Yeah. Yeah. I read a few questions from the chat as well, so we can keep the trend going. There is a question here related to battery circularity market. How does it look like in the UK? And we have quite some EVs, but not so much battery production. So I imagine it's quite small. This is a question from Dominic. Who would like to take this one?
In the chat, I put some names there. So Sonobi started more as a Second Life company and moved into kind of full service mobility and ESS. I think they're doing some good stuff. Connected Energy is there. I think Wykes Engineering is doing it with JLR. Also LI, I never figured out how to pronounce their name. LI Energy.
I have the same problem every time.
If anyone can tell us how to pronounce it, that would be good. There's a few companies doing some really good Second Life projects in the UK.
Okay.
Yeah, and I was just going to add on the recycling side, I saw someone comment about how much recycling is being taking place. But I think something that is really important to make sure happens, whether in the UK or anywhere else, is that the recycling isn't just shredding and then sending the black mass abroad to other countries and having that black mass being processed and the materials kind of leaching out of the system. The hydromet is definitely more complex, I would say, as a process than the shredding, but the values in those materials and in the processing of that and getting back to the kind of raw materials that we use to make the batteries. So I think anyway, there should be a push to encourage not just kind of the black mass shred part, but also the full loop, so that the materials stay within the local economies and then can be reused to make new batteries.
Awesome. Yeah, thank you. There's a few questions also related to logistic challenges transporting into the UK. Is it similar to transporting within the EU? I think this would be for Elias.
Yeah.
How does it work, moving around in the EU, also to UK as well?
Well, first question, positive answer for that is it works. It does work. Obviously, it comes with a few things you have to comply with, a few more regulations you have to fulfill, a few more documentations you have to fulfill, but it is working in both ways. So transporting into the UK or exporting it from the UK, both ways are working. Short answer.
Are there like specific challenges if you had to switch continents, for example, or even within EU, for example? Are they in different countries? Is there like a new, how does it work across borders is what I'm trying to see.
Well,
Yeah, go ahead.
different ways. William, do you want to add anything?
It's just that it's not in the EU. So, I mean, as a third party, I mean, we could ship batteries across the Europe from Sweden, but shipping from Norway or from the UK as non-EU members, we need a local partner who does the declaration of export. So it's kind of those small nuances.
Yes. So there are solutions for any country. You said it. Norway is not part of the EU. Switzerland is not part of the EU. We need working solutions for this. And the good part is you don't have to. Well, our customers don't have to think about this because we will handle those transportations, right?
Very good, very clear. Thank you. Scrolling through to find the questions. There is one from Julian. He says, don't the obligation of the EU regulation towards higher recycling quantities for batteries conflict with Second Life applications on a large scale?
Yeah, I think so. I don't like the recycling content. I think it's a great ambition, but it's hard to determine output of how it should be.
So the quantity they are mandating is where the problem is.
Exactly. So if they say from 2031, they claim that you need X% of cobalt and nickel in new production within Europe. And what's happening at the moment is that why be recycled until then? To reach those numbers, you need to basically recycle everything on the market in 2031. That's not going to happen. It's not going to be here. It's not going to be available. The market is too fragmented and the batteries are leaving Europe. So in order to comply to those recycling quotas in 2031, you basically need to start recycling now, but you can't really use the material because you need some kind of certificate, or you need to trade in that raw material in 2031. Some OEMs are even considering stockpiling used batteries, discharging them, putting them in a warehouse so that they can recycle in 5 years and use the material then. So this demand of a future content of recycled material in cells is kind of hindering the recycling market at the moment, which I think is stupid. At the same time, it's both saying we should prioritize Second Life, but it has a hard number on how much recycled content there should be. And so you can't really have both. And that's why I think it's not very smart to set a hard number on recycling content.
It could be that we just lost my colleague Ola from Bergh. He mentioned in the beginning that he has like slight internet issues. That's definitely a bummer, but he's back. So sorry for the slight technical difficulties. Yes, he's back. Ola,
Yeah,
may I
I'm
give the
sorry.
stage back to you? No worries.
My network went off. Sorry. Yeah, we finished with the last one. Are there more questions in the chat that I needed to go through?
Can I add to the last question a little bit?
Yeah.
Yeah.
I-
On that recycling content, we see that problem here in the Netherlands for e-bikes. So the Dutch compliance organization, they cannot collect enough batteries because we repair too much. So there is a solution, is that we work together. So there needs to be more cooperation between the different parties in, let's say, 2nd-life. And with that, we can put some pressure on the Europe, show how it can be done, and that works mostly.
All right, thank you. There's a question here I can see. I don't know if you treated this. This is, do you see the US market as an opportunity for 2nd-life?
Yeah, more so than in the US or in Europe. I think it's less regulations. It's also the higher imports tax on Chinese LFP systems, so they don't compete with the same prices, which is good. But it's the same kind of technical challenges, the big challenges of integrating different BMSs, different batteries, different degradation, different da. So it's hard regardless. But I think it's a better market than Europe.
There is one more question that just came in now from Dominic. Why do car manufacturers not train people to repair battery packs in the house and instead outsource it? I think this is talking more to skill gap, for example. Do you see a skill gap in the repair of battery packs, and why do we instead outsource this?
Yeah, that's definitely an interesting question. In my introduction, I didn't tell it, but I'm also the founder of SuperB, a battery manufacturer in the Netherlands. And as a battery manufacturer, you are mainly focused on building new products and selling them. And you are not equipped and not trained, and you don't have the perhaps not the permits to do repair. So it's not something that really works. So what we see in the automotive is that they do first diagnostics. For example, you see already that dealers can do some work on it, but in other industries, there's a big gap between the manufacturer and the client, let's say, in what they want, and that gives opportunity. And if you look at what we need to do on permits, on storage, on training, it's quite significant. It's way more than you need to do for new production to do this safely, especially because they are used batteries, and then the insurance gets crazy, let's say. So,
Awesome. Edward, your hands up.
Yeah, I wanted to comment that dealers, at least in Benelux, Germany, in the big European countries, usually have the knowledge to repair the packs. They can open them. They have the necessary training and permits to do this work. They usually have problems with part sourcing, and then the costs to the customer that actually has the car. Sometimes if you have a little dent on the battery pack, you maybe have cycled the battery too much, they can void the warranty. There are some scenarios where, this battery warranty is redeemed not worthy. And that's going to be definitely an interesting point to see in the upcoming time. We have already many DIY shops that can repair car batteries. It's interesting how they get their information, but OEMs is also doing this. It just comes at much more higher expense because if you go to a dealership That's what you have to pay.
Yeah. Thank you for that. A big thank you to all our experts on the panel today. It's been a very interesting discussion. Thank you very much for this. I'm sure we gained quite a lot. I did myself. To wrap up here now, before we move to the networking phase, I would like to give a very short intro for the next webinar we would have like this. Yes. So in the next one, we would dive a bit more into battery repurposing. We would look at some use cases, for example, for when batteries transition from high demand applications, what other roles can they play? The next panelist that we will have as well would probably discuss some of these use cases. We will talk about, for example, the technical parts of this and also some business models. So we'll look at some emerging business cases across Europe. So the link for this would be in the chat to register. My colleague will put that in now. Yeah, it's already there. And you can already register, and we would announce the experts panel as soon as we go. Thank you very much, everyone, for listening. I would hand over now to Maxi.
Thank you so much, Ola. Okay, we've nearly reached the end of our presentation. Thank you so much to all the panelists and the experts for your very interesting insights. A lot of complicated issues we got to work on in the next coming years to make battery circularity an actual thing. Now to wrap it up, we promised networking session. You're gonna get a networking session. Please, for the next like 13 minutes, engage with your fellow like networking enthusiasts and like battery enthusiasts. We're gonna be more people this time than the last couple of times. We're gonna be 4 to 5 participants. Please just engage, network, talk about whatever you think is most interesting, and then we're gonna come back in the plenary for one last time. You can ask any final questions to the panelists, and then we're gonna wrap up. See you in about like 10 minutes. Have fun, everybody. That was the quick 10 minutes. I hope you got the chance. You networked, you engaged, you shared your LinkedIn details. I hope you had a great session. Thanks again. We've come to our end. Thank you again to all the experts, to our panelists for your honestly very great insights and all the stats and knowledge you've shared with us today. Just a quick reminder again, please sign up for the next session, and any input you have along the way, anything you want to see, you can always shoot us a quick message on LinkedIn, send us an email at info@battereverse.eu. What do you want to hear more of? What do you think is interesting? And we'll gladly incorporate into a future planning. And we hope to see as many interested and exciting battery enthusiasts at our next edition of the Short Circuit. Thank you so much, everyone, and have a great afternoon.